This is the elevator control circuit. To get you oriented, these are the buttons to input the floor number of the elevator. So they go from 0 up here to floor 15 up or down here. I'm not able to connect this circuit to the elevator to demonstrate since the elevator isn't working right now. So I'll visualize the outputs that are intended to be fed into the elevator control, which would normally control it if it were connected. And so that would be these two LEDs right here. So this is the down LED. It represents the down input to the elevator, and this is the up LED, and it represents the up input to the elevator. And so how this works, a quick recap, is if both of these LEDs are lit and the up and down inputs on the elevator are fed a high value, then the elevator disengages. When they're both 0, which we won't deal with, the elevator circuit would break. If down is lit and up is not lit, like in this case, it would the elevator would be going down. And if the up LED was lit and the down LED was not lit, then that would mean that the elevator should be going up. And so these jumper wires represent the photosensor inputs. I take these, and we take these inputs in as binary values. From A0 to A3, the least significant to most significant bits, which are represented here. So the white wire is the least significant bit, and the orange wire is the most significant bit. And so as you can see from here, currently what the photosensor is supposed to be sending into the circuit is that the least significant bit is 1 and everything else is 0. So this is 0, 0, 0, 1, which represents floor 1. And so this is what the photosensor reads from the very beginning. By default, what the elevator does is it goes down all the way until it gets to the bottom. So when you start, it looks for and these two green jumper wires represent the elevator output. This is the upper limit switch when the elevator reaches the top of the shaft, and this is the bottom limit switch when the elevator reaches the bottom of the shaft. So these are both hardwired into the elevator circuit so that the elevator will stop when the limit switches are pressed, but also their data outputs that we take in here as inputs. And so both of these are at 0 right now, which means that the elevator is not currently at either the top or the bottom. But now let's see what happens when the elevator does eventually reach the bottom. So the bottom LED the bottom limit switch would trigger, and the photosensor would be reading 0. And so now the elevator knows that that the circuit has reached the bottom, and that the elevator has reached the bottom, and that now it disengages, as you can see from the up and down pins being pulled high. And so now let's say we want to go to floor 0, 1, 2. Let's say 2. So we hold that down, and we see that the elevator is starting to go up. Now we see that it leaves the bottom of the elevator shaft and keeps going up until until it reaches floor 2, which is represented by this binary number here, 0010, which is 2 in binary. And so we see that it stops. And so what happens when we want to go to floor 15? So we press the button, the elevator goes up, and it keeps climbing until the top. Until the top is reached. And so we see that it disengages here. The photosensors are at the top, and also the top limit switch is triggered. And even if it's not triggered, it still disengages like we want it to. And now let's test the functionality of the ground button or the closed door button. So this is right here. What it's supposed to do is once the elevator reaches the desired floor, the user can press it and it'll go back down to ground and not take in any inputs until it reaches the very bottom. So let's press it and see what happens. So we see that the elevator goes down. We can represent that the photosensors also go down, but yeah, this shouldn't make a difference. So this is at floor 12 right now. If we want it to go up to floor 14, we press the button and we see nothing change. The elevator still goes down no matter what button we press, because it's in a state of closed door. And so it needs to get back down to the very bottom before it disengages. And so we can represent that with this, but more importantly, once the bottom is reached, then once the bottom is reached, then this is disengaged. And so yeah, we can also clear the circuit, and by default it's disengaged since it's at the bottom. And yeah, so that's the circuit.